Let us continue ionic equilibrium. In the ionic equilibrium, let us take this sum. Here, Ksp of AgCl is given. Ksp of AgCl is given. Calculate solubility of AgCl in 0.01 molar sodium chloride. That we have to find. Sir, first how to prepare this solution, that we will see. Now we will take silver nitrate solution. We'll take silver nitrate solution. Silver nitrate solution we'll take. To this, let us add sodium chloride solution. Sodium chloride solution we will add. This sodium chloride solution we will keep excess. We will keep excess. Now, silver nitrate solution with the sodium chloride solution gives silver chloride white precipitate. Then above this precipitate, solution will be there. Above this precipitate, above this white precipitate, silver chloride, solution will be there. In the solution, what is present? What is present means excess sodium chloride is present. That sodium chloride concentration is how much in the sense 0.01 molar. 0.01 molar. Then this solution above the precipitate, the solution will be always saturated with respect to that precipitate. So this solution is a saturated solution of this precipitate AgCl. Not only this AgCl, whatever the precipitate you get in any analysis, you are getting precipitate. You are getting precipitate in the sense above the precipitate, mother liquor will be there, solution will be there. That solution will be saturated with that precipitate. Like this only will be there. Set. Now this solution is saturated with respect to what? Silver chloride. Set. Now in this solution, now what they are asking in the sense solubility of silver chloride. Solubility of silver chloride in this solution they are asking. Okay, solubility of silver chloride in this solution we have to find it. So how to find that we will see. Now solubility of AgCl, solubility of AgCl in 0.01 molar NaCl solution, that we want. For which we will take the saturated solution of AgCl, for which we will write equation. For saturated solution of AgCl, let us write equation. That is a saturated solution of AgCl. For that, how to write equilibrium in the sense, write silver chloride solid in the left side, write in the right side ions in aqueous solution, write Ag plus ion and Cl minus ion. Like this we are writing. So, next we will take a solubility of AgCl in 0.01 molar NaCl solution is how much in the sense S molar we will take. S molar. Suppose we are taking S molar. Otherwise X. Otherwise Y. Like this you take. Solubility of AgCl in 0.01 molar NaCl is S molar. Then we will consider assumption this dissolved AgCl undergoes complete ionization. Like this we will consider. Dissolved AgCl undergoes complete ionization. Like this we will take. Okay, complete ionization. Then this dissolved AgCl on complete ionization gives Ag plus. That Ag plus concentration how much means this S molar. How much AgCl is dissolved, that much AgCl is dissociated. Therefore concentration of Ag plus is how much? S molar we can say. Then we will see concentration of Cl minus. This Cl minus is provided by AgCl. AgCl is giving Cl minus how much means S molar. Then sodium chloride also giving Cl minus, that is how much in the sense 0.01 molar. Therefore concentration of Cl minus is S plus 0.01. This S molar is given by AgCl. 0.01 molar is given by sodium chloride. Okay, so concentration of Cl minus how much we have to write means S plus 0.01 we have to write. S molar is given by AgCl and 0.01 molar is given by sodium chloride. Okay, Now we will substitute this Ag plus concentration and Cl minus concentration will substitute. Okay. So now we will write a solubility product. Solubility product of AgCl is equal to concentration of Ag plus into concentration of Cl minus. Solubility product value we will substitute. That is how much given. You see that here given is 1.5 into 10 power minus 10 is given, that we will substitute. So solubility product of AgCl is 1.5 into 10 power minus 10, that we have substituted. Concentration of Ag plus is S molar. Concentration of Cl minus is 0.01 plus S molar. Okay. So we have substituted everything. Now we have to find S. S is called solubility of AgCl in 0.01 molar NaCl solution. Okay. So now we have prepared a saturated solution of AgCl in pure water we have prepared. While we calculated solubility of AgCl, we got solubility of AgCl how much in the sense 1.225 into 10 to the power of minus 5 molar we got. When in pure water, we have prepared saturated solution of AgCl in pure water, their AgCl solubility is this much. Here it is what solution? Here you see that here what solution? This AgCl saturated solution present in 0.01 molar sodium chloride solution. This sodium chloride will give common ion, isn't it? What is the common ion? Cl minus. Due to common ion effect, what happens? Solubility of AgCl getting reduced. So due to Cl minus common ion effect, Cl minus sodium chloride gives Cl minus, that is common ion. Therefore, here equilibrium favors backward. Therefore, what happens means solubility of AgCl is getting reduced. Therefore, this S is there, no? This solubility of AgCl here, this value is less than 10 power minus 5. Therefore, we can take approximation, this 0.01 plus S, we can write it as 0.01, we can write. Let us substitute this one here. So solubility product is 1.5 into 10 power minus 10, solubility into 0.01. Therefore, we are getting solubility of AgCl in 0.01 molar NaCl solution, we are getting, that is 1.5 into 10 to the power of minus 8 molar. Okay, so this is the solubility value. Let us go to next question. Now, here equal volumes of 0.02 molar calcium chloride and 0.0004 molar sodium sulfate are mixed. So, what will happen, that we will see. Now we have to mix calcium chloride solution. We are taking calcium chloride aqueous solution. Let us take, that is volume is V liter. We will take that concentration is how much in the sense 0.02 molar. Concentration of what in the sense calcium chloride. Here concentration of calcium ion is how much in the sense 0.02 molar. Concentration of Cl minus is how much in the sense 0.04 molar. Why? Because one calcium chloride contains two chloride ions. Okay, one calcium chloride on dissociation gives two chloride ions. Okay. Then let us take a sodium sulfate solution. We are taking sodium sulfate solution. Let us take this one, same V liter as like calcium chloride, because they said equal volumes. Okay. This concentration is how much in the sense 0.0004 molar. Now we will see concentration of sodium ion. Concentration of sodium ion is 0.0008 molar. Double we have to write. Concentration of sulfate we will write. Concentration of sulfate is 0.0004 molar. Okay. Let us mix both. On mixing both, we are getting a resultant solution. Resultant solution we got. In the resultant solution, what is the volume of resultant solution in the sense 2V liters? 2V liters. That means volume is doubled. Okay. Volume what happened means doubled, because equal volumes we have mixed, therefore volume becomes doubled. Okay. Now we will see concentration of calcium ion. Concentration of calcium ion becomes how much means becomes off. Divide by 2, therefore becomes off. Why? Because we have doubled the volume. If you double the volume, concentration becomes off. Okay, if you triple the volume, concentration becomes 1/3. Set. Concentration of calcium ion become off, we said. Similarly, concentration of sulfate ion, we'll see. Concentration of sulfate ion also becomes off. Concentration of sulfate ion also becomes off, we can say. Concentration of sulfate ion also becomes off. In the same way, sodium ion as well as chloride ion. Set. Now, on mixing these two solutions, we are getting resultant solution. In the resultant solution, what are the salts possible? That we'll see. In the resultant solution, what are the salts possible in the resultant solution? So in the resultant solution, one possibility is calcium chloride salt. Next possibility is sodium sulfate salt. Next possibility is sodium chloride salt. Next possibility, calcium sulfate salt. Calcium sulfate. So, this calcium chloride is quite soluble in water. Generally, halides if we take, all the halides are soluble in water. That means chlorides, bromides, iodides, all the halides are soluble in water except um, mercurous chloride, silver chloride, lead chloride, lead halides. Lead chloride means lead halides, cuprous halides are insoluble in water. That means then mercuric iodide is insoluble in water, but mercuric chloride, mercuric bromide is soluble in water. So here lead chloride means lead halide, we can say. So these are insoluble in water. Generally halides in the sense soluble. Exception is like this. Then regarding sulfates, all the sulfates are soluble in water except aged calcium sulfate, strontium sulfate, barium sulfate, then silver sulfate, lead sulfate, insoluble in water. Therefore, here one possibility we are getting that this calcium sulfate may be precipitated. That possibility we are getting because that is insoluble. Rest are soluble. Sorry, calcium sulfate is insoluble salt in the sense why we have to say may be precipitated. What is the reason? On what basis we said calcium sulfate may be precipitated? That means soluble salts. For soluble salts, solubility is greater than 0.01 molar. For insoluble salts, what is the solubility in the sense greater than 0.1 molar? For insoluble salts, solubility is less than 0.01 molar. For sparingly soluble salts, solubility in between these two. Therefore, soluble salt means solubility is greater than 0.1 molar. Now we will see. Okay. So calcium chloride we will take. Calcium chloride concentration is how much you see? That is calcium ion is less than 0.01 molar is there. And chloride is 0.02 molar. In the resultant solution means 0.02 molar. That means calcium chloride can dissolve greater than 0.1 molar, but it is less than 0.1 molar only. No, then how do we expect precipitation? No, like that only sodium chloride and sodium chloride. But calcium sulfate, in the sense, it is insoluble salt. It is coming under insoluble salt. Insoluble salt means its solubility is less than 0.01 molar. But calcium, you see, calcium concentration is 0.01 molar is there. Therefore, since it is insoluble salt and concentration is concentration of that means solubility of insoluble salt is less than 0.01 molar, but here 0.01 molar is there. Therefore, may calcium sulfate may precipitate. Sir, whether calcium sulfate may precipitate or not, whether calcium sulfate will precipitate or not, how to know it? For that case, we have to take the point. What point? In the sense, ionic product you have to take and solubility product you have to take. Of what? Of calcium sulfate. So take calcium sulfate solubility product and take ionic product of calcium sulfate and see the relation. If the relation is like this, if the relation is so and so, then calcium sulfate will precipitate. If the relation must be like this, if the relation must be like this, then only we can say calcium sulfate surely precipitates. Okay, so how to write ionic product? Means what expression we are writing for solubility product, same mathematical expression you write for ionic product, but meaning is different. So for solubility product, how do we write a mathematical expression? For that we will write equation. What is the equation? What is the equilibrium? We will write calcium sulfate solid in the left side. In the right side, we will write calcium ions aqueous and sulfate ions aqueous we will write. Now, ionic product of calcium sulfate is equal to right side thing you write it concentration of calcium ion into concentration of sulfate ion. Now, even for solubility product also same expression. If this it is concentration of calcium ion in the saturated solution and it is the concentration of sulfate ion in the saturated solution, means then this product is called solubility product. Ionic product means this concentration can be in unsaturated solution or saturated solution or supersaturated solution, in any solution. Ionic product means. So if you take this product is ionic product, then this concentration and this concentration can be from unsaturated solution or can be in saturated solution or can be in supersaturated solution or anything. Solution can be anything. Solution can be unsaturated or saturated or supersaturated. Under whatever the condition, this product is called ionic product. If you want to say this product is a solubility product, then these concentrations, these ions should be in saturated solution of calcium sulfate. Okay, so now ionic product of calcium sulfate we got. We do not know whether the solution is unsaturated or saturated or supersaturated with calcium sulfate. We do not know. Okay, let us find it and we will see. Okay, now concentration of calcium ion we know that is 0.01 molar and concentration of sulfate ion we know that is 0.0002 molar. Let us substitute these values in the ionic product expression and we will see. Okay, so now we will substitute these in the ionic product expression. Okay, so let us substitute concentration of calcium ion. How much that is? 10 to the power of concentration of calcium ion is how much, in the sense 10 power minus 2. Concentration of calcium ion is 10 power minus 2, isn't it? Sir, concentration of sulfate ion is how much, in the sense 2 into 10 to the power of minus 4. Therefore, we are multiplying these two, we are getting ionic product 2 into 10 to the power of minus 6 we are getting. So ionic product is how much, in the sense 2 into 10 to the power of minus 6. Now let us see solubility product of calcium sulfate. We will see solubility product of calcium sulfate. Solubility product of calcium sulfate is how much given, in the sense 2.4 into 10 to the power of minus 5 given solubility product of calcium sulfate. Now let us compare ionic product and solubility product. Ionic product is less than solubility product. Ionic product of calcium sulfate is less than solubility product of calcium sulfate. Therefore, calcium sulfate will not be precipitated. will not be precipitated. Like this means solution is unsaturated with calcium sulfate. Okay, if the condition is so and so, then only calcium sulfate will be precipitated, otherwise no. Now we can say calcium sulfate is not precipitating in this one. Okay, now they have asked that will a precipitate form, in the sense no, precipitate is not forming because the resultant solution is unsaturated with calcium sulfate, therefore precipitation is not possible. Okay, now we'll go for this question. Here, what is given, in the sense solubility of lead hydroxide is given. Lead hydroxide in water is given as a 6.7 into 10 power minus 6 molar is given. Okay. So 6.7 into 10 power minus 6 molar is given. Okay. Now here we will see in the previous question, once again we will see the previous question. In the previous question, solubility product is given 2.4 into 10 power minus 5. Ionic product we are getting as a 2 into 10 power minus 6, isn't it? Therefore, ionic product is less than solubility product. Therefore, no precipitation is possible. Okay, sorry. Now we will go for next question. We will go here. Solubility of lead hydroxide in water is given. Calculate solubility of lead hydroxide in a buffer solution of pH 8. Sir, here they are saying that PbOH twice in a buffer solution. They are saying PbOH twice in a buffer solution. Which buffer solution we have take? PbOH twice in a buffer solution means which buffer solution we have to take? Is there any condition for that? We have to take so and so buffer solution. Here they said buffer solution. Buffer solution, in the sense, for buffer solution they have given even pH also. This buffer solution is which buffer solution? How to know it? This buffer solution comes under which category? How to know it? Which buffer solution? They have not mentioned. Sir. So we will take a buffer solution. We are taking a buffer solution. To this buffer solution, let us add PbOH twice precipitate. PbOH twice precipitate. Sir. PbOH twice precipitate we added. We are getting what, in the sense resultant solution. In the resultant solution, what is there means buffer solution is there. This buffer solution is having how much pH, in the sense pH is equal to 8. In the resultant solution, PbOH twice present. PbOH twice is present in the resultant solution. In the resultant solution, what is present, in the sense PbOH twice is present. In the resultant solution, we are saying that PbOH twice is present. We are saying that solubility we have to find it. That means the resultant solution is what, in the sense saturated solution of PbOH twice. The resultant solution is what means saturated solution of PbOH twice we have to take. Sir, saturated solution of PbOH twice means we have to write the equilibrium. How we have to write equilibrium means left side we have to write PbOH twice solid. Right side we have to write Pb2 plus aqueous, and OH minus aqueous we have to write. Okay. Then for this we can say that solubility we have to find it. Okay. Solubility of PbOH twice we have to find here. Sorry. So solubility of PbOH twice we have to find. That we will take it as S molar, we will take it. So concentration of Pb2 plus how much, in the sense S molar. if you consider PbOH twice undergoes complete ionization. And concentration of OH minus is 2s plus here buffer solution they have given. Therefore, buffer solution in the sense this PbOH twice present in this buffer solution, this resultant solution pH is how much in the sense 8. pH is 8 in the sense pOH is equal to how much means 6. So concentration of OH minus is equal to how much means 10 power minus 6. Therefore, we will write concentration of OH minus how much in the sense 10 to the power of minus 6 we will write here. Okay. So concentration of OH minus we will write 10 power minus 6 molar. Why? Because pH of solution is given 8. Therefore, pH is 6. Therefore, concentration of OH minus is 10 power minus 6. Therefore, 10 power minus 6 we have written. Okay. So, concentration of Pb2 plus is S molar. Concentration of OH minus is 10 power minus 6 molar. Now, what they are asking means calculate solubility. So, we will take solubility product expression. We will go for solubility product expression. Solubility product of PbOH twice is equal to concentration of Pb2 plus we can write into concentration of OH minus power 2 we can write. Okay. So, we have written like this. Now, solubility product of PbOH twice how much given in the sense that is not given, we have to find it. Solubility product of PbOH twice we have to find and we have to substitute, then only we can find this Pb2 plus concentration, that is nothing but solubility of PbOH twice. So, how to find solubility product of PbOH twice? For that case, first statement we will take. The first statement says that PbOH twice we are dissolving in water, we are getting solubility. We are getting solubility how much in the sense 6.7 into 10 power minus 6 molar they said. That point we will take. Okay. So, for which let us take a PbOH twice solid we will take. To this we will add water, pure water we will add. We will prepare what in the sense saturated solution of PbOH twice we will get. Saturated solution of PbOH twice we are getting. Sir. For this, what is the equilibrium in the sense? Left side we have tried PbOH twice solid, right side we have tried Pb2 plus aqueous and OH minus aqueous. OH minus aqueous we have written. Now we will write solubility product. Solubility product of PbOH twice is equal to concentration of Pb2 plus into concentration of OH minus square we have written. Now, they have given solubility, they have given solubility word, they have given solubility of PbOH twice in water is given. That is how much in the sense solubility of PbOH twice in water is given, that is equal to 6.7 into 10 to the power of minus 6 molar given. Solubility of PbOH twice in water, that is 6.7 into 10 power minus 6 molar. Okay, that we know. Now, if PbOH twice completely dissociates, then concentration of Pb2 plus is S molar, concentration of OH minus is 2S molar. Okay. So, we will write a concentration of OH minus is how much in the sense 2S molar we will write. Then this square we will write. Okay. So, concentration of Pb2 plus is S molar we will write. Concentration of OH minus is 2S molar we will write. Square we have written. Therefore, 4S cube. Now we will substitute solubility. Solubility is 6.7 into 10 to the power of minus 6 whole cube. So we are getting what in the sense solubility product of PbOH twice we got it. Okay. This we will substitute in a previous case. Okay. Solubility product of PbOH twice we are getting, that is 1.2 into 10 to the power of minus 15 molar cube. Okay. This we will substitute. So now we got solubility product, that is 1.2 into 10 power minus 15, that is equal to concentration of Pb2 plus is S molar, concentration of OH minus is 10 power minus 6 square. Therefore, we are getting solubility. Solubility how much in the sense 1.2 into 10 to the power of minus 3 molar. Okay, so we got solubility of PbOH twice in water we got. Set. So for this question, what is the answer means 1.2 into 10 power minus 3 molar, that is the solubility we are taking. Okay. Now we will go for one more time previous equation, previous expression we will see. Here calcium chloride how much given in the sense 0.02 molar is given. in this question. Calcium chloride is 0.02 molar is given. So concentration of calcium ion is 0.01 molar. Concentration of sulfate is given is so and so. So on doubling the volume, concentration of sulfate becomes half, we said. Sorry, next we will see ionic product of calcium sulfate. Ionic product of calcium sulfate we are getting, this is 10 power minus 2. Calcium ion is 10 power minus 2. Sulfate is 2 into 10 power minus 4. Therefore, ionic product is 2 into 10 power minus 6. Solubility product we can write it as 2.4 into 10 power minus 5. So, if you write this one as a, this we can write it as a 24 into 10 to the power of minus 6. Can we write 24 into 10 power minus 6? Yes. Now see the ionic product 2 into 10 power minus 6. See the solubility product 24 into 10 power minus 6. Therefore, ionic product is less than solubility product, we can say. Therefore, calcium sulfate will not be precipitated. Okay. This is correct only. This sum is correct only. Okay. Now we will go for next sum. We will go. Now we are going for next sum. Okay. In this sum, determine the concentration of ammonia solution. Determine the concentration of ammonia solution whose 1 liter can dissolve 0.1 mole AgCl. Ksp of AgCl and Kf of AgNH3 twice plus are given. Sir. Now, let us see about this one. In the salt analysis, in the practical, salt analysis will be there in the inorganic. In the salt analysis, some salt will be given. Question is, we have to do the experiment. We have to do salt analysis. We have to do. Then we have to report what is the cation present in the given salt and what is the anion present in the given salt. We have to report it. That is a salt analysis in the practical. That is one part. In this salt analysis, one anion is chloride. One anion is what means chloride. Suppose the given salt is aluminum chloride, we will take. In the salt analysis, what is given means aluminum chloride salt is given, that is white, that is solid. You are doing analysis. You are doing analysis for aluminum ion and you are doing analysis for chloride ion. For that, some procedure is there. That procedure we are following. Okay. For anion analysis, what we will do in the sense, this salt we will dissolve in water. Then what we will add in the sense, silver nitrate solution we will add. Okay, silver nitrate solution we will add. Okay, what we will get in the sense, AgCl white precipitate we will get. Okay. So this salt name we know, so that we said here. Suppose we do not know name of the salt. What is the anion present in this given salt? We do not know. We are doing this test. We are coming for this test. We have taken the given unknown salt. We are dissolving in water. We are adding silver nitrate solution in the pure water. Everything we are using pure water. Okay, tap water we are not using because tap water contains chloride. That's why. So distilled water we are using or pure water we are using. Pure water we are using and we are doing the test. Okay, so the given salt we have taken, we are dissolving in water and we are adding silver nitrate solution. If we get white precipitate, then we can say the given salt contains chloride. If we do not get white precipitate, then we can say chloride is absent. Okay. Then suppose if the given salt contains sulfate, that with silver nitrate, okay, that with silver nitrate, what will happen in the sense, if the given salt contains sulfate, that with the silver nitrate gives what in the sense, silver sulfate. It is also white precipitate. Okay, if the given salt, suppose copper sulfate salt is given. Copper sulfate salt is dissolving in water. If you dissolve that one, it will dissolve in water. to that silver nitrate solution you add, you will get white precipitate, that is silver sulfate. So now we have to find the salt is which salt we have to find. For that case only we are doing salt analysis. Okay. So the given salt you are dissolving in water and you are adding silver nitrate solution. If we get white precipitate, one possibility chloride, another possibility is what? Sulfate. Two possibilities are there. How to confirm which one? For that what we have to do means take ammonia solution. In the ammonia solution, two ammonia solutions will be there in the lab. One is called liquor ammonia. Another one is called ammonium hydroxide solution. So liquor ammonia means concentrated ammonia. Ammonium hydroxide solution means diluted ammonia. Ammonia is added in water and we prepared ammonium hydroxide solution. That means aqueous solution of ammonia is called ammonium hydroxide. Okay. So you are adding dilute ammonia solution to this. Dilute ammonia itself enough. Otherwise concentrated ammonia also we can add. What will happen means silver chloride white precipitate dissolves due to formation of complex. That complex is this one. That complex is this one. This complex is quite soluble in water. Silver chloride white precipitate dissolves in ammonia solution due to formation of complex. But the silver sulfate white precipitate does not dissolve in ammonia solution. So from this we can confirm that the given salt contains chloride. If the white precipitate dissolves in ammonia, then we can say the given salt contains chloride. So like this we can do the experiment. Okay, so now we will go for the question. Here what is the question? We'll see determine the concentration of ammonia solution whose 1 liter can dissolve 1 liter can dissolve 0.1 mole of AgCl. Okay, that means ammonia solution you are taking how much? 1 liter you are taking. That concentration we have to find it. Ammonia solution concentration we have to find it. It is dissolving how much silver chloride? 1.1 mole of silver chloride is dissolved. So we will take silver chloride. Silver chloride is solid because it is insoluble salt. To this you are adding ammonia solution. How much ammonia solution you have added? 1 liter you have added. 1 liter you have added. Silver chloride, how much means 0.1 mole. Okay. Now, silver chloride dissolves in ammonia due to formation of what in the sense complex. Complex is what in the sense AgNH3 twice Cl. This complex is quite soluble in water. Okay. How much AgCl dissolved? Complete. 0.1 mole is completely dissolved. Remaining is nearly 0. Okay. Now, how much complex is produced? 0.1 mole of complex is produced. 0.1 mole of complex is produced because they said what they said, this ammonia solution can dissolve. Therefore, silver chloride is completely dissolved. Okay. So silver chloride we are taking 0.1 mole. 0.1 mole of silver chloride is completely dissolved in ammonia solution. Therefore, we got 0.1 mole of complex. Okay, so we got a 0.1 mole of complex, we got it. So now what we have to find? What is the concentration of ammonia solution we have taken? So we have to find a concentration of this ammonia solution, we have to find it. So now we have to find the concentration of ammonia solution, we have to find it. To find the concentration of ammonia solution, what are the supporting points given in the sense? One is solubility product of AgCl is given, then formation constant of complex ion given. Formation constant of complex ion given. Now let us write a equation for these. Okay, first solubility product of AgCl. For this, how to write equation that we will see. Okay, so solubility product of AgCl, if you want what equation you have tried means the equilibrium present in saturated solution of silver chloride, that you have tried. That is AgCl solid is in equilibrium with Ag plus aqueous and Cl minus aqueous. For this equilibrium constant is solubility product of AgCl, that is how much in the sense 1 into 10 power minus 10 molar square given. Set. Another data given is what in the sense formation constant of complex ion is given. For that how to write? Formation constant of complex. Formation of what? Formation of complex. What is the complex given? AgNH3 twice plus formation of this complex. So left side what you have tried? Constituent species you have tried. This Ag is having this plus 1 charge. Therefore, you write Ag plus aqueous. Here bracket is having NH3, that is called ammonia. You write NH3. Balance it. Keep 2. Okay. For this equilibrium constant, we can say formation constant of complex. Formation constant of complex, we can say that value how much in the sense 1.6 into 10 to the power of 7 molar power minus 2. Then let us add these two. What we are getting, we will see. Now AgCl solid is there. Then we will cancel this Ag plus aqueous, we will cancel in both sides. Then here what is there means 2 times ammonia is there. Then gives this complex is there. Right side complex ion is present and chloride ion is present. Okay. Now for this we can write equilibrium constant Kc is equal to what we can say, right, means concentration of this complex ion into concentration of chloride ion by concentration of ammonia we can write. Now this equilibrium constant Kc we can get by multiplying this Ksp and Kf. Okay. If you multiply this equilibrium constant and this equilibrium constant, we will get this equilibrium constant, we will get it. Okay. Therefore, this equilibrium constant Kc is equal to Ksp of AgCl into Kf of complex. So we know this Kc value. Equilibrium constant value we know. If you know concentration of this complex ion and concentration of this complex this Cl minus, then we can find concentration of ammonia. We can find. They are asking us to find concentration of ammonia. Okay, sir. Now first we will write this equilibrium constant. This is equal to what? Ksp into Kf. Ksp into Kf. Okay, we have written equilibrium constant. We have written. Then what we have to substitute in the sense concentration of complex ion we have to substitute and the concentration of Cl minus ion we have to substitute it. So now concentration of complex ion, what is the value? What is the value of concentration of complex ion? We'll see. Now you see that we got this complex 0.1 mole we got in this one. This complex in aqueous solution is in the form of dissociated ions. This complex salt dissociates in water as what in the sense AgNH3 twice plus cation and anion. Okay, this is the complex salt. This salt is dissociating to how much extent they did not say in the sum. Therefore, we will consider complete dissociation. Okay, so complete dissociation. This salt is how much is there? 0.1 mole. It is dissociating how much? Completely. Therefore, complex cation we are getting 0.1 mole. Cl minus we are getting 0.1 mole. Both we are getting 0.1 mole. Now concentration of complex ion we want. We know number of moles. Volume of solution how much they said? 1 liter they said in the sum. 1 liter of solution. So 1 liter, we know volume, we know number of moles, so we can say the concentration. So concentration of complex ion, we know concentration of Cl minus also we know that we will substitute. So concentration of complex ion is 0.1 molar, concentration of Cl minus is 0.1 molar. From this we will get concentration of ammonia. They are asking us to find concentration of ammonia. They are asking us to find. Okay, so we are getting a concentration of ammonia. We are getting. Okay, sir. So concentration of ammonia we are getting, that is how much in the sense 2.5 molar we got. We got concentration of ammonia. We can simplify this. So we got concentration of ammonia. Now we will see what they asked in the question. So they are asking that Determine, you see the question again, determine the concentration of ammonia solution whose 1 liter can dissolve 0.1 mole of silver chloride. That means, are they asking what concentrated ammonia solution we are taking? They are asking. Otherwise, at equilibrium they are asking. You think it. Okay. So now we will see here. This is we got concentration of ammonia. Concentration of ammonia we got from this expression. This is what? It is nothing but equilibrium concentration of ammonia. Equilibrium concentration of ammonia, isn't it? Why? Because for this equilibrium only, no, we got this expression. We have gone for this expression for this equilibrium. Therefore, this NH3 concentration we got 2.5 molar. That is called equilibrium concentration of ammonia. Correct? Sir. So we got equilibrium concentration of ammonia. But what they are asking? Initial concentration of ammonia they are asking. What ammonia solution we are taking? What concentrated ammonia solution we have taken? That's what they are asking. So we want initial concentration of ammonia we want. We know equilibrium concentration only. Sir, now we how to know initial concentration, we'll see. So we have taken 0.1 mole of silver chloride. This 0.1 mole of silver chloride consumes how much ammonia do you know? 0.2 moles of ammonia. 0.2 moles of ammonia in order to give 0.1 mole of this complex. Okay. So the silver chloride consumes 0.2 moles of ammonia. Sir. Now at equilibrium, how much concentration is there? Means 2.5 molar is there. How much ammonia is consumed by silver chloride? 0.2 molar is consumed by silver chloride. Here volume is 1 liter, therefore moles we are saying as molar. Okay. So the silver chloride is consuming how much ammonia? In the sense 0.2 molar ammonia silver chloride is consuming. Therefore, what initial concentration we must taken? 2.7 molar, because silver chloride is consuming 0.2 molar, remaining is 2.5 molar, means initially what must be taken? 2.7 molar we must be taken. We have taken 2.7 molar. Therefore, initial concentration of ammonia is how much? In the sense 2.7 molar we can say. Okay. So